You're not going to want to miss this episode of the AI Show where we talk all about evaluating Azure AI Foundry agents with my friend Chang. Make sure you tune in. Hello and welcome to this episode of the AI Show where we're talking all about evaluating Azure AI Foundry agents with my friend Chang. Thank you so much for being here, my friend. How are you doing?
Doing well. How are you?
Great. And so, I've recently been learning a lot about agents and AI agents, and my sense is that these things are different. And because they're different, you need to kind of test them differently as well. Is that intuition good, Chung?
Yes. Agents can be powerful productivity assistants, enablers. They can increasingly plan, make decisions, or interact with other agents to create more complex workflows for business needs. With tools empowering them, they can increasingly, automate the process of making decisions, even and taking actions on behalf of stakeholders or other agents.
And because of that, my sense is that you need to test these differently, right? And you brought some slides. What are we looking at here?
Yeah, so the main value add of agents is to automate business workflows, and starting from human workflow where humans kind of take up both the sensing and the response and the action stages in the cognitive task. Now with AI models, we move on to RAG apps where the AI model can increasingly do the sensing part. And now with tools, models plus tool equals agent in my working definition, you are enabling agentic workflows where increasingly productivity can be unlocked from automating these business workflows.
Yeah, that's cool. And my sense is that because there's like this new kind of breakdown, like you're breaking up all the tasks in a really specific, concise way. Everything I've seen is for evaluating just models, but my sense is that now you need to evaluate like tool stuff too. Am I off here? And if I'm not, how does one do such a thing?
There's one more piece of context I want to kind of introduce, and
Yes.
it is probably a well-known saying that AI is going to eat software, And I think right now we're in the episode agent computation, where if we flip back not 100 years, but only one decade or two, in the beginning of ML, machine learning, probably familiar to some of you, that we thought models are amazing, magical beings. But it ends up for any ML systems to be productionized, we end up writing way more code than the piece of layer inside the model. So it is really like a lot of code and model taking up only a very small layer. But now I think where we are moving is agent is going to eat up more and more code. In the future, with empowered by tools, these models are going to make very intelligent decisions on behalf of the developers. So we are really seeing the paradigm shift here that agent is going to be taking up more space in the software.
Yeah, and to me that this was a revelation for me too, when I first started doing function calling, where I realized that like now with AI you can translate unstructured like text, image, whatever, and convert that into call this function. And so now this notion of like coding around models is kind of reversed. The model is generating code for you to actually run. I wanted to see if that intuition jives with your thinking too.
That's right. Agent can invoke specific tools that you have built for them, custom Python function that you have prepared for them, or it can write code on the fly and execute.
Wow. So that's even further than what I was thinking.
So with that big promise, there comes the problem of agents as a black box, because we have delegated all these tasks to the agents. there's a very urgent need for developers to enable observability into the black box. For quality evaluation, we care about, like, as from a point of view of a developer, how do I debug my agentic system to improve? Did I call the right tool calls? Is the user intent identified correctly? Is the task at the end of the day fulfilled according to system instruction? And I talked about security and vulnerability, right? Did it generate malicious code, right? These are very important questions that we need to unblock developers and make observability much easier than it currently is.
Yeah, and and this is addressing much more than just the naive kind of like, hey, is the prompt okay? Is it calling the right tool? You're going even further than that. Are the right tools being called? Is the user intent correct? Is the agent acting and behaving properly? Which is really cool to me.
Yeah, and I kind of typically think of the agent workflows in several stages, and we can kind of reenact them a prototypical agent workflow. Say they have a user asking whether tomorrow, then there is an aspect in the system that would resolve that intent to down to specific things. And then they would call the right tools and then generate a final response. There, every step of the way, we can evaluate these aspects: intent resolution, tool call accuracy, and the final response evaluation in terms of task adherence and response completeness. And then the things that the evaluation aspect we still care about in the RAG era, we still want to evaluate them throughout the agent user interactions as appropriate. These would be RAG quality, for example. In the last step of the way, we generated a final response based on the retrieval results of the tool calls that we have made, right? So RAG is not out of the way. It's actually still very present. And also risk and safety. We need to worry about code vulnerability more than ever. And therefore, we need to evaluate and provide observability into the system that we are building to automate our workflows.
Yeah, and it feels like now, like this breaks it down so much better. I just want to, like, I'm going to move my face, but like this breaks it down into, we want to observe every aspect of what the agent is doing, from its internals to its output, from the input to the internals to the output. And this is what this, I think, is saying.
Yeah, so to enable observability into this, developer using Azure AI Agent Service can seamlessly evaluate their agent through our converter support for Azure AI agent threads. While we are planning for more converter support for different agent data formats, developer can still use evaluators' low-level API to evaluate their agent data. But without further ado, let me bring you the seamless agent evaluation experience for Azure AI agents. So here, I could start building an agent using Azure AI Agent Service. I created a new agent, and I run the agent to generate data for evaluation.
This notion of a thread. What is a thread, and why does it need it? Because I know why, but I want to hear like how you think about a thread, because this may be the first time someone's seeing the concept of a thread.
That's a great question. So the concept of a thread is defined by the assistant, OpenAI's assistant API, where you can think of it as a conversation. The boundary of a conversation is the thread, that you have all the context within it, that a user interacts with the agent on similar topics, and the user can generate multiple runs. The developer can generate multiple runs based on the user agent interactions. Kind of think of it as we move on from one topic still within the conversation to another topic related, and then to another topic. You can kind of think of it as different runs within threads. So threads and runs, they're kind of hierarchical conversation concepts.
I see. So a thread, let's see if I get this right, and then maybe correct me. So a thread is like a conversation history over a particular run. Is that right? Or are there multiple threads per run, or are there multiple runs with the same thread? How does that work?
Multiple runs within a single thread.
I see. So essentially, so a thread is like a conversation history-ish, and I can start up an agent and give it the thread of the conversation so it has context on what's been going on. And you can even, could you transfer that thread across different agents and different runs?
The thread history should preserve the entire conversation history. So at a particular run, the agent would have access to previous run data. For example, it might remember something you talked about in previous runs.
I see.
That is stored in that thread run relationship.
And this makes more sense now, because like evaluating this, the thread is going to become an important part, is my sense, on how we evaluate these things. Or is that not the case?
That is the case.
All right. Let's move on to the next thing. Sorry about that.
Oh, no worries. And then after we have created the agent, we have run the agent to generate data, and this is called a run within a thread. And a thread, as a conversation holder, could have multiple runs, and they're interconnected because current run will have the memory or context of previous runs. And here I have invoked my Azure AI Agent Converter support, where I can just provide a specific run ID, and then I can convert that run from the agent to the required format that our intent resolution, tool call accuracy, and task adherence evaluators know how to do proper evaluation. So here you can see single run eval results. You can just dump that data into that evaluator and know how to do it.
This makes a ton more sense, because it's actually the thread and the run together that you can evaluate the agent against, which makes total sense to me. And let me move my face so we can see the code. Yeah, this is cool. And what kind of results does it produce?
It will give you this. It will give you basically a score. For example, on intent resolution, a Likert scale score, basically an integer 1 out of 5. And then we also allows the user to pass in a threshold, so that if it's worse than the threshold the user provides, it will generate a fail. And this fail is a flag, is a basic unit for essentially kind of a unit test concept for a single run of an agent workflow, so that the user would quickly find which run has problems, and then they can dig into it for more further details. For example, we generated, based on LLMs, reasons why the LLM judge thinks that the agent response is failing for intent resolution. And there's even further debugging details, so that the user find, did the conversation even have intent? But sometimes if it doesn't have intent, right, it has implication on the scores. Whether I, as a developer, care about it, it's very contextual. And also provides you the perceived intent by the agent, or the actual intent given by the agent. These debugging details enables user to have more observability into a particular agent run.
Yeah, this is extraordinary. Like it's something that my developer spidey sense told me I should be doing. But the fact that you can run these things with a thread and with a run, and then get analysis of like, hey, this agent is behaving the way you want to, is awesome. Because you could probably put this as part of you could probably do this inside of a GitHub action and run stuff as you check things in to see if things are working, right?
That's right. Yes, absolutely.
That's cool. Okay, so what else you got?
And so your agent probably generate not just one single run, but probably multiple runs within threads. And you probably have multiple threads. So in this case, we want to batch evaluate your agent so that you can know which one of your many agent runs failed and quickly identify the issues across different runs. So here, again, I'm invoking my converter support. We can just use this one-liner to prepare all that data that there is for pertaining to this thread ID into the evaluation data and invoke our batch evaluate API, select the evaluator that we care about, and also optionally, but highly recommend you using our Azure AI project so that you can go to Azure AI Foundry for a rich visualization experience. And we can take a look right now into that.
Yeah. So before we go there, so I think what you're saying is that I can run all these things locally if I want to, but if you point it at an Azure AI project and Azure AI Foundry, you're going to get some really rich visualizations as well. Is that right?
That's right. Yes.
All right, let's take a look.
Here you're seeing the Foundry Evaluation UI page. Under data, we can quickly see row by row of the many single agent runs that we have created. So across the different runs, we find that most of them are passing, but there's this failing on intent resolution as well as tool-call accuracy. So that's very concerning to me as a AI developer. I want to know why this run didn't work. So I quickly go to the explanation for the intent resolution, and it tells me that the agent response does not address the user query about the best tense available. It looks like the user is asking for best tense available. It perceives the intent. However, it didn't really find the answer. And also the to call is failing too. And here I find the to call accuracy is false. And the reason is because the to call is not relevant to the user query. And it doesn't make sense in the context of the conversation. So here I quickly go to the agent's last response, and I see what the agent is doing. It says the search results from the uploaded documents do not contain specific information about best tense available. So basically, the agent is calling the wrong tool, and therefore it couldn't find the right information to answer the user. And that gives me clues on how I should basically look into that specific tool that I care about.
Yeah, like as you're going through there, like this is actually really cool because there's a chain of things that went wrong that caused the thing to not work. It chose the wrong tool, and because it chose the wrong tool, it provided a bad answer that wasn't grounded in the question, or wasn't, didn't respond to the question. And now with this observability, you're able to see where in that chain it failed, where before it was kind of like a black box.
That's right, exactly. I can drill into as far as the details that I can find from this particular agent tool call. And it turns out that it is calling, file search on a set of HR documents, even though my question is asking about the best tense available, which seems to me as a human, it makes sense that this should fail.
Yeah, because it's not doing the right thing at all. This is really cool. Is this stuff available for people today?
Absolutely. And here we have the documentation for how AI developer users can onboard to this SDK experience to enable observability today.
This is awesome. So let me finish up by saying this is awesome. number one. Number two, you kind of showed some documents, but can you tell us about each of these documents we put up? So the first is the end-to-end evaluation experience for Azure AI Foundry agents. This is the first place where people should go. This is the example that you were showing us. Is that right? Or is it something different?
This is the documentation that walks you through how to onboard to the end-to-end experience, which we walk through step by step, and at the end we do the batch evaluation.
Okay.
So this is the right place to go.
Cool. And then this is a conceptual document. What will people find in here?
This is the how-to documentation. If for people who are interested in knowing more about the concepts of these specific evaluators that can evaluate agent threats, they can go to the concept doc here.
Love it. And then finally, this is how you actually call the thing. Is that right?
To actually call the thing, you go to the how-to doc.
Oh, I see. And so the SDK documentation is basically the API shape. Is that right?
Yes. And then to run the notebook from end to end, you can go to the sample notebook section, and where you can put everything together, and this will help you run your Azure AI agents evaluation seamlessly in one notebook.
Awesome. Well, this has been amazing. Thank you so much for being with us, my friend.
Thank you very much for inviting me. This is
absolutely
a lot of fun.
Yeah. And thank you so much for watching and learning all about evaluating Azure AI Foundry agents, my friend Chang. Thank you so much for watching, and hopefully we'll see you next time. Take care.